The transition from fossil fuels to renewable energy offers a pathway to decarbonize our planet and foster a more sustainable future. However, the coin has two sides, and this shift can be a double-edged sword. Often, the complexities and challenges of this transformation are overlooked, but they are crucial because that's what will dictate whether our homes and urban landscapes flourish in sustainability or struggle to adapt. And architecture is one of the key contributors to making this transition smooth and successful. My name is Anton Dobrovsky, I'm an architect and have been a passive house consultant for over 9 years now, so I want to share with you the challenges of the renewable energy transition and the impact of thoughtful architecture on it. But before that, let's zoom out, look at the big picture and understand where we spend most of the energy. It might surprise you, but buildings are actually the largest energy-consuming sector worldwide. According to the United Nations Environmental Programme Global Status Report from 2022, buildings account for 34% of the total energy consumption worldwide. Now, consider where this energy comes from. Globally, a staggering amount of energy is still generated from non-renewable sources. In fact, only about 29% of our energy comes from renewable sources. This is a small fraction, especially considering the urgent need to shift towards more sustainable energy solutions. And this heavy reliance on non-renewables for our buildings has significant implications. It's not just about the high energy bills or the strain on our power grids, it's about the larger environmental impact. And the burning of fossil fuels for electricity and heat in buildings is a major contributor to greenhouse gas emissions, which drive climate change. And that's why countries are committed to achieving net zero emissions by 2050, aiming to limit global warming to 1.5 degrees Celsius and prevent global catastrophes. So when we talk about the transition to renewable energy, it's not just an environmental slogan, it's a critical shift that needs to happen, especially in the building sector. By integrating renewable energy sources into our buildings, we can significantly reduce the environmental impact. However, the transition towards clean energy comes with its own set of challenges. One of the primary hurdles is the timing mismatch between renewable energy production and consumption. Solar energy, for instance, peaks during the sunny hours of the day, often when most of us are away from our homes, resulting in less immediate demand for this energy. On the other side, our energy usage typically increases in the evening, just as solar energy availability declines. And this mismatch presents a logistical dilemma. So, the energy we generate isn't always available when we need it most. And this discrepancy poses a challenge for energy storage and distribution systems, as they need to store this excess energy efficiently and make it available during off-peak production hours. But for now, these storages are very expensive and they are not very efficient. Another challenge is the geographical distribution of renewable energy sources, which adds another layer of complexity to this transition. Ideally, renewable energies like wind and solar should be harnessed where conditions are most favorable, such as sunny deserts or windy coastlines. However, these ideal locations are often far from urban centers where energy demand is the highest. And this spatial disconnect requires a robust and efficient energy transmission infrastructure to transport the energy from remote generation sites to urban consumption centers. And the efficiency loss during this transmission and the cost implications of setting up such an extensive infrastructure are significant challenges. Additionally, the environmental impact of developing these remote sites and the associated infrastructure, including concerns about land use and ecosystem disruption, must be carefully considered and mitigated. And speaking about clean energy infrastructure, we should also mention electrification. Electrification means replacing technologies or processes that use fossil fuels like internal combustion engines and gas boilers with electrically powered equivalents such as electric vehicles or heat pumps. And that's not just exciting, it's electrifying, but electrification also presents its own set of challenges in the renewable energy shift. As we increasingly turn to electricity to power our vehicles, heat our homes, and run our appliances, the demand for electricity is set to rise dramatically. This growing demand, fueled by the move away from fossil fuels, is a positive step towards reducing greenhouse gas emissions. However, it also means that our existing electrical grids, which were designed for a different era of energy use, need to be significantly upgraded to handle this increased load. Without careful planning and upgrading of our electrical grids, this increased demand could overwhelm our current infrastructure, leading to power shortages and reliability issues. Furthermore, the increased demand for electricity highlights the need for advancements in battery technology and energy storage solutions. These technologies are essential to balance the load on the grid, especially during peak usage times, and to store excess energy generated from renewable sources for later use. And all of these are critical challenges that should be addressed in order for the clean energy transition to take place. And we've already mentioned that the building sector is the biggest energy consumer with 34% of the total energy consumption. But what is this energy actually used for? Well, a study by the International Energy Agency from 2020 shows that 56% of the energy is used for space heating and cooling. So a substantial portion of the energy used in buildings is dedicated to heating and cooling our buildings. But this means there is also a huge potential for optimization, because we should ask ourselves a very simple question, namely, where do we lose the heat from? Well, the very simple answer is through the building envelope, right? We heat the indoor space, outside it's cold, and the heat flows from the warmer to the colder environment. And because we are easily losing the heat, we have to provide additional heat to our buildings in order to keep them warm and cozy inside. And for hot climates, that's reversed, of course. So what can we do in order to minimize the energy demand? Well, one option is not to use as much heating and use less electricity. The problem is we're becoming more and more spoiled, and no one wants to live like that. You want to have the lights on when it's dark outside, you want to have a warm and cozy home when it's cold outside, so using less energy for the sake of compromising comfort is not really an option. The good news is that there is also another solution. With innovative architectural design, we can significantly reduce this demand. By focusing on enhanced insulation methods, we can retain more of the heat during the winters and keep buildings cooler in summers, thereby reducing the need for external heating and cooling sources. This is not only conserves energy, but also cuts down on utility bills. And that's exactly what the Passive House Standard does. It combines the personal interest and desires of the individual with the public need for environmental protection. Passive house buildings have a significantly reduced energy demand and use 90% less energy for heating and cooling compared to standard buildings. And this is achieved by minimizing the heat losses and making most of the natural resources available, like sunlight and air, in order to maintain a comfortable indoor environment. And therefore, passive houses are energy efficient, comfortable, and affordable all year round. And once we've minimized the energy consumption by following the passive house design principles, it becomes much easier to meet the remaining energy needs with renewable sources right on site. This is where the integration of renewable energy into building design plays a pivotal role. For instance, incorporating solar panels on roofs or integrating wind energy solutions can significantly offset a building's energy consumption. These technologies not only provide clean energy, but also move buildings towards self-sufficiency in terms of their energy needs. And as we look towards the future, the potential for buildings goes beyond just being energy efficient. We're looking at a future where buildings can be energy positive, meaning they generate more energy than they consume. This excess energy can then be fed back into the grid, contributing to the overall energy supply. This concept represents transformative shift in how we view our buildings, not just as structures, but as active contributing elements to our energy ecosystem. And therefore, the role of architects in this renewable energy revolution is fundamental. Through thoughtful and sustainable design, architects have the power to shape not just the aesthetics of buildings, but their functional role in a sustainable future. They're at the forefront of designing buildings that align with our environmental goals, pushing the boundaries of what's possible in sustainable architecture. It's through their vision and innovation that we can transition towards a world where buildings are integral to our renewable energy solutions, paving the way for a more sustainable and resilient future. And as you saw, the first step to achieving this is to make buildings more energy efficient. So if you want to see a project that incorporates the Passive House principles into its design and pushes the boundaries of sustainable architecture, check out this video.